So we need to prove the following. So let's begin from the left hand side. So we have cosecant theta minus sine theta. Now we know that the cosecant function, that is the reciprocal of the sine function. That means cosecant of theta is equals to 1 over sine theta. We're going to replace cosecant of theta with 1 over sine theta minus sine theta multiplied to, we have secant theta. Now secant theta is the reciprocal of the cosine function. So we have 1 over cosine theta. So that gives us 1 over cosine theta minus cosine theta multiplied to tangent of theta, plus we have cotangent of theta, and we know that cotangent of theta, that is the reciprocal of a tangent function. So we have 1 over tangent of theta. So we have tangent of theta added to 1 over tangent of theta. Now 1 over sine theta minus sine theta, that's going to give us 1 minus sine squared theta divided by sine theta whole multiplied to, we have 1 over cosine theta minus cosine theta, so that's 1 minus cosine theta, the cosine squared theta divided by cosine theta, and we have tangent squared theta plus 1 divided by tangent of theta. Now here we'll be using some identities. The identities being we know that sine squared theta plus cosine squared theta, so that value is equals to 1. So using this identity, we can rewrite the numerator 1 minus sine squared theta as cosine squared theta divided by sine theta. Similarly, 1 minus cosine squared theta, we can use the same identity and replace it with sine squared theta divided by cosine theta multiplied to, now we have 1 plus tangent squared theta in the numerator. Now here we'll be using the identity that tangent squared theta plus 1 equals to secant squared theta. All we have to do is remember this particular identity, and since we need a tangent function here, so we are going to divide throughout by cosine squared theta. So sine squared over cosine squared is going to give us tangent squared theta. Cosine squared theta over cosine squared theta, that will be 1, and 1 over cosine squared theta will become secant squared theta. This is going to give us secant squared theta divided by tangent theta. Now couple of terms will get cancelled out, factored out. We have cosine theta from the new denominator and 1 cosine theta from the numerator. Then we have 1 sine theta from the denominator and 1 sine theta from the numerator cancelling out. And then we have, let's write it down. So we are left with cosine theta times sine theta multiplied to secant squared theta divided by tangent theta, but we're going to take the tangent theta to the numerator, so we can use this identity. So reciprocal of the tangent theta will be the cotangent function, so we have cotangent of theta. Now furthermore, we will get cosine of theta times sine theta. So secant squared theta, this can be replaced with 1 over cosine squared theta, and cotangent of theta, that's the ratio cosine theta over sine theta. So now we have cosine theta times cosine theta, that's cos squared theta, so that gets factored out with the cosine squared theta in the denominator, and sine theta also gets factored out, leaving us with 1, and this is the expression on the right hand side. So hence we have successfully shown that they are given expression, given trigonometric expression, this value is equals to 1, hence proved.